Good evening. Welcome to the channel. Physics Fun. Today we have to learn work, power, and energy. Work, power, and energy. Let's take the first topic, work. Work. What is work? If we're running on the road, we do some work. If we're lifting something from the ground, we're doing work. So now, what is the basic concept of the work? Let us consider a horizontal path. Let us consider a horizontal path. An object is kept on the surface of the path, and a force, capital F, is applied on the block. It makes an angle theta with the horizontal. Now, if we resolve the force into the two components, we have F cos theta is the horizontal component and F sin theta is the vertical component. Now the block is moving along the horizontal path. So the work done, we have to consider the work done by the force F cos theta. If it crosses a distance S, then the work done is equals to F cos theta force into displacement S. Now here we know that for the cos theta, F dot S. So the work done we have F dot S. So we can say that the work is a scalar quantity. Is a scalar quantity. Now let us consider about the different cases for the work done. Now first consider the formula. You already find it. W is equals to F dot S, which we can write F S cos theta. Now if theta is 0 degree, what it means? An object falling under the influence of the gravitational force in the downward direction, or in which direction the gravitational force works, that work done is called the work done by the force. So W is equals to Fs cos 0 degree, that is equals to F into S. Now here we can also consider what is the positive work done. What is positive work done? If theta is less than 90 degree, that is theta is the acute angle, then W should be positive. That is the work done should be positive. It is the first case. Now let's move to the second case. If we consider theta is equals to 180 degree, theta is 180 degree. If we put it in that equation, we have W equals to Fs cos 180 degree. Now what is the value of cos 180 degree? Is the -1. So we have W equals to minus F into S. What we get? That is the negative sign. For what negative sign comes from? When a body lifting in the upward direction, just opposite to the gravitational force acting in that direction, the work done should be negative. Okay, that is the work done against the force. Work done against the force. The work done against the force. Now, what is the negative work done stands for? If theta is greater than 90 degree, that is obtuse angle, then we get the work done is negative. Now let's move to the third case. Third case is the W is equals to F dot S, that is equals to Fs cos theta. Now if we consider F is equals to 0 but S not equals to 0, first case, F not equals to 0 but S equals to 0. Now third case, F equals to 0 and S equals to 0. Then for that, those of the three cases, we have W equals to 0. That is, no work that takes place. Now let us consider theta is 90 degree. Theta is 90 degree. Then work done is equals to W Fs cos of 90 degree. What is the value of the cos 90 degree? Is 0. So we have W equals to 0. Now how to understand practically it? If we're moving in that direction, that is the displacement is, okay. Now the weight of the object acting in the vertical direction, in the downward direction, that is the mg. Now here mg is the force, F. Mg is the force. Now what is the angle between F and S? Is the 90 degree. Then the work done by the gravitational force W equals to F S cos of 90 degree, that is equals to 0. Work done is 0. Okay, we understood the practical application of that theory. Now let's move. What is the constant force and the variable force? Before to move that topic, what is the unit of work done? What is the unit of work done? What is the unit of the work done? The SI unit is joule and the CGS unit is the arc. Those are the practical units. Now what is the gravitational unit? Gravitational unit. The gravitational unit of the CGS case and the SI case. CGS is the gram weight centimeter, and for the SI it is kg weight meter. Now what is the relation between joule and arc? So the 1 joule is equals to 10 to the power 7 arc. Okay, now let's move to the constant force. Now let's move to the constant force. What is constant force? A force is constant by its value. If we consider the 1 Newton, 2 Newton, 3 Newton, 10 Newton and the 12 Newton, 20 Newton, so on, those forces are constant. Okay, now let's take an example. A force F is equals to I hat plus 2 j hat plus 3 k hat. Here is no variation because for the I hat we get 1, for the j hat we get 2, and for the k hat we get 3. Those are the constant. So work done, if s is equals to 2 I hat, so work done is equals to f dot s for the constant force, that is equals to I hat plus 2 j hat plus 3 k hat dot 2 I hat. So I hat dot I hat is 1, we get 2, and others components are 0 because there is no j hat and k hat in the displacement. Okay, now let's move to the variable force. Now let's move to the variable force. Variable force, that force depends on time or the distance, etc. Right? Let's write F is equals to 2t I hat plus t square j hat plus t cube k hat. So here the force depends on the time. If the time, if that is the force is time dependent, t equals to 1, we get the force at different value. For the t equals to 2, we get the force another value. So it is a variable force. Now the displacement s is equals to 2 I hat. The work done W is equals to F dot S, that is equals to 2t I hat plus t square j hat plus t cube k hat dot 2 I hat. I hat dot I hat is 1. So we have 2 into 2, 4t. Work done is 4t. Now, for the variable force, we can find the work done in the graphical method. Graphical method. Let us consider Ox, Oy, two axes. Now Oy is the force axis, right? And Ox is the displacement axis, x. Now consider a graph like that. If we consider a strip, this is a strip, and the displacement is dx, right? Displacement is dx. Initial is xi, and the final is xf. So here, for the small strip, the work done dw is equals to f into dx. Now to find the total work done, then total work done w is equals to integrating xi to xf f dx. This is the x component displacement, right? This is the variable force. dw equals to f into dx, integrating xi to xf will get the total work done. Now we here discuss about the conservative force, and non-conservative force. Two topics. What is the conservative force? Let us consider a block at that position. If we take it to the height of h, from that path, mass is m, height h is mgh is the work done. If we take it through that path, the work done will be same mgh, and if we take vertically in that direction, the work done is same, that is the mgh. So that work done is independent of the path. So that force is the conservative force. Now to prove it, how to prove it? That gravitational force is conservative force. Gravitational force is conservative. How to prove it? Let us consider an inclined plane making an angle theta with the horizontal, and ABC. First we take it through a distance S, and that is h height. Along AC, what is the work done? Now if we consider the block at that position, mg acting in the vertical downward direction, so here that angle is theta, and this is mg sin theta, and this is mg cos theta. Now the work done along AC is equals to mg sin theta into S. Now from the triangle h by S, that is the altitude by hypotenuse, is equals to sin theta. So h is equals to S sin theta. Okay. Now putting it in that case, we have WAC is equals to mgh. Now if we lift that block from B to C, the work done will become WBC equals to mgh. So the work done for the different path is same. So that gravitational force is conservative force. Now what is the non-conservative force? Non-conservative force. Now what is the non-conservative force? Let us consider point A, that is B. Work done along that path is W1, along that path is W2, and along that path is W3. So here W1 is not equals to W2, is not equals to W3. That is the non-conservative force. What is the example of the non-conservative force? Is the frictional force, is the viscous force, etc. So that topic is completed for the first class of the work, power and energy, and we will come soon with the another topics of the work, power, energy. And for the day, goodbye, stay tuned, please subscribe, like and comment my channel.